So let's start with the first course. This is a quick introduction to the Linux Unix command line shell. What are we going to cover in this course? So we want to learn what is the command line shell and why do we need that? And once we've figured that out, we're going to learn to navigate files and directories, how to work with files and directories. We learn a little bit about pipes and wildcards, and then we do some sequence analysis. So why do we need this command line shell? First of all, once you got a little bit used to how to work with that, it's rather efficient. So I encourage everyone to get familiar with it and use it as much as possible. The real reason is, though, that most bioinformatics tools that we are using on an everyday basis only run on the command line shell. So there's no graphical user interface where you can use a mouse to click around. Those tools exist, such as maybe Genius or CLC Workbench, but the tools that are just newly developed by bioinformaticians will typically run via the command line shell, and you need to know what this is in order to run them. The other thing is that sequence data is typically very big. Genome sequences are very large. So we cannot always run bioinformatics tools on our desktop computers, but we might require a high performance computing environment, so the HPC. And typically, to interact with an HPC head node, you need to use the command line shell as well. So some of the tools we are going to cover in the further courses, such as the RNA-seq and the sequence analysis, will require the command line shell. So this one is pretty much a prerequisite if you want to go through the follow-on courses. So what is the command line shell? Typically, it just looks similar to this here. And you will have this on several computers. You will have a terminal on a MacBook. You will have a PowerShell on a Windows computer, or you have these terminals or command line interfaces on Linux machines. So what typically happens is that we see something like a dollar here. We call this dollar a prompt. Whenever there's the prompt, we can type in a command and hit enter. And if that command is meaningful, the computer does something that is similar to double-clicking on some program. Okay, so just a little bit of an outlook. I talked about we type in some programs. This is about the typical commands that we use on the everyday basis when we run that. So it just fits on one slide, which means it's not that daunting. Before we just immediately go into playing with the command line, if you want to do some further reading, or rather complementary reading, there's a lovely course which is part of the software carpentry selection of courses. And if you go for the shell novice, that covers everything that we go through in this course and also goes a little bit further. Right, so I stop my presentation for now. So let's start the virtual machine. Just go from the very beginning. Somewhere here, I have my virtual box, which we fire up. And in here, we have imported the Wheat Bioinformatics virtual machine. So let's get this started. In the video, we make a little bit of a break. You probably need to hit pause until you've caught up and started up your virtual machine. So the virtual machine for me is loaded up now. This is a Linux system. So in this Linux system, we have a desktop, like for example in Windows. So here we still have a mouse and we can click around, we can do things. But also, and this is the interesting part why we are using this virtual machine. We have this terminal, and this terminal is very similar to what we typically get on an HPC. So here we have our terminal, we have our prompt, this dollar symbol. And if we type in commands here and hit enter, something will happen if the command is meaningful. So for example, if I type pwd and hit enter, the computer responds, giving me an answer, and also comes up with a new prompt so I can type in another command. So this is the way how I can interact with the computer via the command line shell. I type in a command, hit enter, and I get a response, or which may be something printed out to the standard out in the terminal, or maybe something else that is happening. For example, starting a bioinformatics analysis. So pwd is a command that stands for print working directory. And what it basically just tells us is where we are currently in the file system of the computer. So just because we are also having a nice desktop here for training purposes, we can always see what's going on. So here, if we have our file explorer, we can at the same time look what's going on. And typically when you start up your terminal, you will start in the home directory, which is, if we're looking at the path /home/userj. If we click here, this is also our home directory. The similar, like typing in the pwd command, we can type in another command, ls. And ls simply means list everything that is in my current directory. And you can see the output here, bin desktop downloads git, is similar to what we have here. Bin, we have a desktop, we have downloads, and git. This is bin data desktop documents, bin data desktop documents. So everything here is the same as we have here. So either we click around, or we can get the same information by typing in a command here. So we have used ls now to display the names of directories in our current working directory. So these commands can also be modified with options. They can be called flags, and sometimes we even can add additional arguments. So if I type in ls minus capital F, the output is slightly modified. So this capital F means I want to modify the output of list. And in this particular case, I want to classify whatever this is. So you can see that a slash is added to each of these names. And this means in the particular case that these names are all directories. So if you are here in your Explorer, you could click into each of them and see what's in there. So very briefly, we can just try to create a file in this directory. I just use a random program here. Let's use LibreOffice. And I just save a file. Save as, this needs to go not in documents, but it needs to be in our home directory. And let's call that test. So hopefully this has appeared here now. Okay, we have a new file. We can close LibreOffice. So if I type ls, I now have a different file. Our command line shell is also very nice and has every directory in blue and the files here in white. But let's ignore that for now. If we use ls-f for classify, we have behind every directory the slash. We don't have a slash behind our file name. And there are other options that we can use, for example, ls-s. So what does that do? It puts some sort of number in front of every directory name or in front of the file name. We'll figure out later, hopefully, what that means. So if we want to know what all these what all these flags mean, or how many flags are there, what are they, we can type ls and then minus minus help. And then we have a very long list of things which we can scroll through. So this is where I typed ls minus minus help. And then we first have the standard usage. So it tells us you can type ls, and then you can add options, and then you can add files. And then here we have all the modifications, the flags or arguments and options we can use. Here's the minus f, and it says append indicator to entries. So very often we have these additional options as a short option. So 1 hyphen and 1 letter. And for each of them, we also have a long option. So here this would be minus minus classify. So this long option might make a little bit more sense. So we know immediately, please classify the list output. This is clearer than the minus f. Why do we have the minus f at all? Just because we always have to type, and we might not be willing to always type minus minus classify. If we know our way around and we have memorized these commands, we can very quickly type ls minus f. It goes much faster than ls minus minus classify. The same reason why we type ls for the command that just lists everything. We don't want to type list because we use ls very often. We don't have to type 4 letters, just we have 2 letters now. So this concept of short options, long options, and also this minus minus help is very common for most programs. So we can get the help for the pwd command. This has very few options. So I said in between very shortly that we also have arguments, but before we go into arguments of list, let's quickly check what happens if we do something wrong. So if I type ls, then minus j, if you would scroll through here, you would struggle to find the minus j simply because it doesn't exist. So this is something that the computer doesn't know. In that case, we get immediately the response, I don't know what minus j is, so please type minus minus help to get more information. So if you do mistakes typing this, you get an immediate help and maybe some more information how to move on. The same is true if I type in some random commands that the computer might not understand. So this is just some letters. It will tell us command not found. Okay, so might be very trivial, but it's useful to know that you always get a response from the computer. Okay, so let's get into the first exercise. Exercise 1. You can use ls to list files in your directory. We've learned that. So now try to figure out what happens if we add the option -l. And then try to figure out what happens if we use both -l and -h. So you can add a number of different options. Try to play with that and find out what they mean, how it works. And then once you've done that, you can try the option -t. So this will sort the ls output by time of last change instead of alphabetically. So play with that as well. And there's also the option -r, which will reverse the sort order. So what happens if you use both at the same time, and maybe think a little bit about why that might be useful. Okay, so the way we do it in these exercises is you run your exercise, you stop the record, the video now, play with that. When you think you have the answers, you just continue with the video, and we'll go through solutions together. Okay, so I hope you had a little play with ls and looked into the ls minus help, what it is. So let's go through the first part together. Look at the option -L and -H. So if we type ls, we have our normal output. If we type ls -L, we get a much longer output. So if you looked up what that is, -L is for the long option. So we get lots of different information here. But at the end, we also see our names of directories and files in there. And then we have additional information. Here's a number. That might be interesting. We'll look into that. And then here we also have a date. That might also be interesting. Okay, so if we have ls -L and then we add the -H, something changes. And I hope you spotted what has changed. The change is here in this number. So here we had 4096 and the file has something different. So this 4096 seems to be specific for the directories. In fact, this is the file size, and the directory itself doesn't have a proper size other than the information about this directory name. So here, for this file, it might be more interesting. Here we have 6924. And if we go down a little bit here, it translates this into 6.8K. So this is now, instead of the bytes that are displayed, this is translated into kilobytes. So here, if we use ls -L and -H, we get the kilobyte or megabyte or gigabyte size, especially when we get into the range of gigabytes, so billion bytes. It will be a lot of digits to decipher and to figure out how much it really is. So having just a 5G rather than a 5 and 9 zeros there is much more convenient. So this is ls -L and -H. How could you figure out what that is? First of all, you could just type it in like I did, and then see what happens and try to determine what it did. We could also use ls -help and just immediately look it up. So where's our L and H? So here we have the H means human readable. So human readable sizes. And where's our L? Use a long listing format. So there you get immediate help. Obviously, what always works, instead of typing the -help, you can Google the commands. If you type in Linux command line shell and ls, you will get extensive information about that. So although we show how to use this help, which is directly in the system, never underestimate the way that you can just type in the things and Google it. Okay, so that was the first part of the exercise. The second part of the exercise was to use the sorting by time in the reverse order. So -T will sort by time. How does it look like? Suddenly we have a slightly different order of the things. And you could see here this starts with a B, and then we had the D, E, and so on. So this is just alphabetically sorted. And here we have a seemingly randomly order. But if we use this ls -L and -T, we can see that the files and directories are now ordered by time. So this is the newest one. And then so on, this is the oldest one. So if we add the additional option -R, ls minus l minus t minus r. We have the whole thing in reverse order. So why could that be useful? This is very useful for data management. If you are in a folder that you haven't touched for a while and you want to know what files might be so old that they are unusable or that they are not usable anymore, or you might be able to get rid of them, you just do this minus t minus r, and the things that are listed first, especially when you look how old they are, you can see when they have been last modified. So that might help you to decide how to clean up your directories. Okay, so that was exercise number 1.